It's the computer video. Ah, it's fine.
What's up? Here we are. It's me and Albert. We're about to dig into scaffold-eth. I would just want to show you scaffold-eth, get you like acclimated with it. Maybe we'll build something little. Let's just do like a little like 45-minute speed run and just like build something just to do it. Sound
Love
good?
it. Super excited
Awesome.
for this.
You want to share your screen and we can get started?
Yeah.
Awesome.
Cool. Let me
I'll
share.
probably do some backseat driving. That's usually how this goes.
Oh,
Sorry,
that'd be great. That'd be great.
in advance.
I get to absorb your knowledge through my fingers over Zoom.
Awesome. Okay,
Yeah.
so first thing is just getting scaffold-eth set up. Like, okay, so first of all, you at home, he's at speedrunethereum.com. If you're a developer, you want to get from Web 2 to Web 3. If you want to get into Web 3, go to speedrunethereum.com. It will help you. and at the top of Speedrun Ethereum, other than that intro video, it basically says go get scaffold-eth and learn these basic concepts like global units, primitives. Look at that handsome guy. He's still got this shirt on. Best Ethereum shirt there is.
I need one of those shirts.
Yep. I just wear this shirt every day, I think. Like all the videos. Yeah. Okay. So do you want to jump into scaffold-eth real quick and we can show like the setup? Yeah. So it's a GitHub repo. You clone it down, you yarn install, you yarn chain. It basically is your full local host development environment. It comes with Hardhat as the back end and Create React app as the front end. If you have a command line set up,
I love
just go to here.
I have an example one. Clone. You want to do that or should
so this is challenge one. Let's go to like just a blank scaffold-eth. What someone would see if they were to clone down just blank scaffold-eth. Yep, exactly. There we go. And maybe close that other challenge one so we don't get confused. Yeah, there we go. So scaffold-eth, yeah, it comes with Hardhat and Create React app. You'll have to get some terminals up and running, but if you follow the instructions on the GitHub repo, it's pretty easy. So yeah, let's see. There we go. Yeah, so we're just going to run a yarn install. I think you already ran that. That one takes like 10 minutes because there's so many dependencies. The next is yarn chain. So you want to fire that up. There we go. And that's going to give us a Hardhat node, right? So now we have a local Ethereum running, a local version of a chain running, right? And then the next one is yarn start. So if you set up another terminal and do a yarn start, this is going to fire up our front end. So now we've got a back end and a front end. And then the last command you need to run is a yarn deploy. And it says it right there in the repo, but there we go. Yeah. And that's going to take an example smart contract. It's going to compile it. It's going to deploy it to your local chain. Then it's going to take the artifacts and inject that into your front end. So now we should be able to go to localhost 3000 and we should be able to interact with our smart contract. And that's what this is all about. Like scaffold-eth is all about getting in this like dev loop of like making a small change to your smart contract, deploying it, and then tinkering with it to make sure it works. Let's just see if this all comes up. There we go. All right. And this is nice right here, right? This is something that comes with scaffold-eth. It detects what network your wallet is on and it switches you. But yes, there we go. You logged out. And that's what I want to do. I want to start with just like burner wallets because burner wallets are kind of a strange concept to folks. A burner wallet. So if you notice this, you have this like this E62, right? You have this address and you don't have any kind of wallet connected. And what that is basically a burner wallet. It's a private key and local storage, but this is super, super handy for development, right? You can go ahead and click that button there to get some funds from the faucet and it'll just like charge up your local account with like $20 or something, right? Oh no, $10. The price of ETH has changed. Yeah. Okay, here we go. So let's get in and let's start debugging our contract. So if you go to debug contracts, it's going to show you basically an interface to your smart contract, right? And if we go back to our smart contract, we should see what this looks like in Solidity. There we go. Hardhat and then contracts. There we go. Awesome. And let's add like a little owner. Let's do a like address public owner equals. Yeah, let's just create a new data type here or a new date. Yep, there we go. Address public owner equals, and then let's just paste in your front end address. Yep, grab that right there. Woo, speed demon. Awesome. And then deploy that thing, right? And this is what it's all about. Small change to the smart contract, yarn deploy, and then go tinker with it in the front end. If you go look at the front end now, we should see this change. This will change in a second. You shouldn't even have to hit reload. Look at that. And there's the owner, and we're set as the owner, right?
Got it.
So let's go.
That's
let's just
so
go try
cool.
to
So
like,
wait, so it's just reading all the state
purpose.
variables here, and like, so owner was
Yep.
a state variable, and it was like,
Yep.
okay, got it.
Yep. Exactly. And so let's just like tinker with the smart contract first. Let's like, let's make sure we can set the purpose, right? There's some string purpose, and then there's some function that lets us set the purpose. Woo! And there we go. And you set it and it sets it, right? Okay. So let's write our first rule. Let's write a quick require statement. Like one of the most powerful things you can do with a smart contract is have a set of rules, right? On line 20, let's just set a require statement that says message.sender has to be the owner, right? So we say, yep, message, yep, equals owner, and then maybe a comma after that and add a little message that says that you're not the owner or something like that. Yep. And then semicolon and ship it. And then, so how would we go about testing that? This is the next thing, right? So now we have a smart contract where only the owner can set the purpose. So let's go back to the front end. Let's make sure we can set the purpose as the owner. I am the owner, right? Okay, now here's how we test the opposite. Here's how we set up a bad guy. If you open up a new incognito window, you'll get a new set of local storage. So if you go to localhost 3000 from this address, and can we kind of pull it up so we have both windows kind of side by side? Then we can see that we have like kind of brown address. We have E62 over on the right, and then we'll have a new address over on the left, and we'll consider
that in the top right too.
Yep, exactly. We'll see this new address. I don't know what's taking it so long. There we go. There we go. Oh, they're both kind of brown dudes. It's kind of hard to tell. Maybe. Oh well.
We can do another one. We can do another one.
Yeah. It's easier when like one's blue and one's green.
There we go.
There we go. We got pink or purple or something, right? Okay, so let's give purple or pink some money from the faucet. And then let's go try to set the purpose with purple or pink and see what happens.
Okay, so
let's see. Will it work? It shouldn't, right? We should get only owner, right?
Nice.
So we were able to write a rule. We were able to kind of test it and make sure it works. And we can do all of that from the front end without writing a whole bunch of tests. And it's a very visceral, like I'm poking at the thing and seeing what it does. So it really helps you kind of like just set it up and understand how this could work. So the next thing we should do.
Yeah.
Yes, exactly. Let's go back to our smart contract and let's change it. So let's make on line 19, let's make this function payable. So people can like actually like put in some money, and then let's change our require statement to be message.value greater than or equal to. So basically we're preparing ourselves. I think at the beginning of this call, before we hit record, we decided maybe we would make like a dice game. So I'm imagining like someone's going to put in some money and we need to check to make sure that money's fine, and then we'll do something else. So let's just do like message.value greater than 0.001 ether or something like that, right? And you do a space, yep, right? And go ahead and hit say. Oh, maybe your message is probably not enough, right? Right now it says only owner can update.
Oh,
but
yeah.
Now we're doing, maybe something like not enough or something like that. Yep, there we go. Ship it. So we just totally, by changing that one line, we just changed the whole mechanics of the smart contract, right? Instead of letting just the owner get in here and attest to something, now it's more like a vending machine. Anyone can get into this thing and anyone can pay a little bit of money and they can set the purpose. So whether you're using the good guy on the right or the bad guy on the left, anyone can use it. Let's use the bad guy on the left. Let's say hello world and let's pay a little money.
Yeah.
It's kind of hard to see because it's so like scrunched. Like maybe we don't have to have them side by side
anymore.
anymore.
That the front end updates with like the paying option immediately.
Yeah, it noticed. It noticed that you made it payable, so it gave you a new transaction. Yep. So if you put 0.001 and just 2 zeros, right? That one's not going to work.
Actually, legitimately pay.
And then hit the little green, you'll have to hit the little green star. I make developers take it times 10 to the 18. So they mentally know, oh, I'm going from ETH to way here, right? It needs to be in way when we talk to, and go ahead and hit send now. And now that should work. There we go. So we changed our smart contract from an attestation machine to more like a vending machine that lets people pay. One more line of code. I love this, like where we add one line of code, everything changes.
Oh, I love it.
Let's go back and let's replace the 0.001 ether with like a price variable. So let's create a new variable up by where you have owner that's called price, right? Yeah, there you go. So uint 256 public price equals 0.001 ether. There we go.
And then
And we make, okay, now here's the line I want to add. Right after someone pays, so like line 22.
Yep.
Let's put in a new line there and let's say price equals price.
Update it.
Yes, exactly. Price equals price times 100 divided by, or times 101 divided by 100.
Times 101 divided. Oh, okay.
Yep. So you can't do decimals, right? We did a decimal up there, but then we followed it by ether, and that takes it times 10 to the 18.
Right.
If you're using, you can't use yet decimals in your calculations here. So see how we do price. First, we take it times 101, and then we take it divided by 100. Basically, all we're doing there,
1.01.
Yep, exactly. All we're doing there is setting the price up by 1% each time someone, but we've just created a dope ass price curve where whenever someone sets this, the price goes up by 0.1%. And that's super powerful, right? That's really cool.
Right.
So let's go make sure it works. And then we're off to the races with actually like building a production level app next.
Love it. Love it. I'm stoked. Okay. Deploying, and then we can,
there we go.
So I can like, this is the first.
Yep.
First price. This should work.
Yep.
Nice.
And then look, your price goes up. You can even just double click on that price and copy it where it's
Oh,
101
price right here. Yeah,
yep,
I got it.
Yep.
Got it.
You can copy that and paste it in to your form and then do your second one. Yep. And look at now the price goes up again, right? It's going up 1% each time someone sets the price. So we have this nice little price curve. By the time we get to the 10th or 100th entry, the money's going to be a lot more, right? Okay, so let's say our app is solid and we're ready to ship it, right? Let's go ahead and put this app as it is on Ropsten real quick to try it out.
Yeah, totally.
Actually, we got time. Maybe we should write the Dice app, knowing that we have a little bit of time ahead of us. Maybe we should write the Dice app first and go to Ropsten with it when we're done.
That's fine. Yeah, that way we don't have to do it twice.
We don't have to deploy the whole thing to Ropsten twice, right? Okay, let's assume that we can go to Ropsten whenever we want. At this point, we're just tinkering. We want to make a dice game, right? And randomness is particularly tricky on chain. You can do things like commit reveal. You can do things like use the previous block hash. You can do things like use Chainlink's VRF. There's a lot of different solutions, but there's something new coming out with proof of stake Ethereum where there's like this RANDAO session where all the validators are doing this like, they're doing this like ceremony where they're committing random numbers to the chain as they go. And so this is still attackable.
That's part
really weird way.
New in the beacon chain.
It's the beacon chain. Yep,
that's
exactly. This dog right here. Yeah. What's new? What's a way that they can still attack it is if I'm a validator and I'm about to validate a block, and that specific block is like the transaction that pays out the lottery or something like that, right? And I check to see, does the lottery pay me out? And if it doesn't, I can basically withhold the block. So there's still like a tiny bit of like weird validator shit that can happen here, but let's just like assume that that's like a far enough off case that like this is at least like way better than block hash. If you're minting an NFT using block hash, you can start using block.difficulty instead when we go to proof of stake. And we're going to put this thing out on Ropsten, who's already on proof of stake, that should have block.difficulty. So block.difficulty used to be like the arbitrary amount of proof of work you had to do. But they're gonna fill in that block.difficulty with this the pre-RANDAO number. And I don't know if you can like guess it or whatever. We're just gonna assume that block.difficulty gives us a random number. Okay, let's just assume that. Okay, so let's go to our Solidity code and let's tinker around. I have no idea what block.difficulty is set to for the local hard hat node. So let's just get a look at it, right? And one of the very first things I talk about doing in speedrun Ethereum is learning the globals. Let's just have a function that spits out block.difficulty real quick. So let's just make a view function. I'm guessing it's going to returns a uint256. Yeah, get difficulty. It'd be a public view function too. You'll want to add that. Yep. Oh yeah, here he goes. Public view, returns a uint256, and let's just return block.difficulty. And let's ship it and see what we get.
On local.
I have no idea what this is going to return, so we'll have to see, kind of just like roll with the punches here.
All right, deployed, run and updated, everything.
And you can close one of these out, right? Let's get rid of the bad guy and just have the good guy here.
All right, let's do that.
There we go. Nice. All right. Okay, whatever, whatever. Okay, so it's that number, but let's assume that it's just going to be a really big number. I think the best way to do this is just to hash it. So okay, so another really cool thing about scaffold-eth is that it's a starter kit, and lots of people have used it to build other starter kits and build other things. So you can always go to, let's go to scaffold-eth where you are here. If you scroll up, search for loogies, just LOOGIE in the branches. Nope, if you'll scroll up to the branches right here. Yeah, see, is Loogie SVG NFT. There we go. Go to Loogie SVG NFT. And then go to packages, hard hat. Whenever you use something that's scaffold-eth, everything is going to be in the exact same place. You know where your go to contracts. And then let's go to the your collectible. This is just like an example. So first of all, this is an example I use for just like a good SVG NFT, where it's a really simple, like, here's how you make an SVG NFT. But this is the example I always use for getting randomness. If you scroll down a little bit farther, keep going. There we go. See that predictable random, like line 45, 143. There we go. That's what we need. Just copy and paste. Actually, I think we want the next row also, where it's shifting to a bytes 3. And let's just do predictable random real quick. Okay, let's just grab that one line.
Yeah, we can do one.
Copy paste it back to our get. Okay, so yeah, instead of, there we go. Okay. Yep. So let's have this. Let's see. So predictable random. So it's going to do a catch act 256. So it's going to get a hash of, and then it's going to encode the previous block hash, the sender, the address, this, and the ID. Let's pull out the ID and the block hash of the block number, and let's replace that with just block.difficulty. So we're gonna, or the whole thing. Yep, there we go. So what we're going to do to get randomness is we're going to hash the difficulty, which should be a random number, with the person who's accessing it, along with the address of the smart contract. IDK. We're calling it pseudo random, right? We're just playing around. We're just learning. We're just trying to figure it out. I think this is going to be a pretty good source of randomness once we go to proof of stake.
We'll rename this random.
Yeah, decent random. I like that. Okay. So now we have a shitload of randomness. We have like 32 bytes of randomness. Let's say we only need like, you know, a random number from 0 to 256 or something like this. We'll do some kind of mod on it. And I'm not sure exactly how we can do this yet. Let's see. That looks all good. So technically this could compile, right? If you wanted to. Let's do something before let's do a console log. Have you ever messed around with console logs?
Hard hat console.
Hard hat?
That we have that.
Yeah, we've got it. Yep. So right up here, let's just do on line 22, let's do console.log, and let's just do decent random at first. And let's just do a semicolon and let's ship it. Actually, no. Let's get,
am I doing this one?
So we have 32 bytes. Let's just get out ahead of it, just because like compiling and testing takes a little time. Let's select, so let's do square braces and let's select the 0th of the random. So now we have just 1 byte, and let's go ahead and type def that to a uint8. So I would wrap that whole thing in a uint8 with, there we go. Now let's see if this thing compiles.
All right, let's do it.
Let's see. Will it go? Hopefully what will happen is every time we ask for a randomness, it'll give us like a little number in the console log, right? So go ahead and hit.
Oh, right, in the console log.
Yeah. And then if we go to, no, it's actually in the hard hat node. We need to go to the hard hat.
One we're running here.
And then if we scroll up, hopefully there's a console log. See the console log of 234. Awesome. Okay, so technically I think what we're getting is we're getting a number from 0 to 255. It's
the first byte. 8. Okay.
Yep. If you wanted maybe a dice roll where it's only like 6 outcomes, you could do a modulus there and do uint8. Maybe let's do that real quick just to prove to ourselves we can. Just do like mod 6 or something like that, right?
Something like this.
Then it's a dice roll. What does it not like that? Okay.
You'll
Yeah.
just keep this
And
slow.
let's do, so the get random is actually, no, it's fine. It's weird that it's a view function and we're doing a console log in it because it's like, that makes it a write function, I think, but I don't know. It's working. Somehow it's working. So
Wait, the
it's fine.
console.log is only local to hard hat though, right?
Yeah, exactly. And when we deploy it to Robston, we'll pull that out so we don't have all that overhead.
Right. We should just like
we need to
return
remember to
this
do
value
that.
or something.
Yeah, exactly. Yeah.
Okay, cool. Let's just test it real quick. So
Let's test it real quick. Let's go watch our hard hat node and let's see that we get, a number between 0 and
4.
There we go. It's 4,
Nice.
right? Okay,
Sweet.
cool.
Okay,
Okay,
we
but
can
I
return
kind of,
this instead.
I kind of like the 256 actually, like a 0 to 255. So let's say,
Okay,
okay, we have to come up with our game now. Now that
Right,
we have our randomness,
What's
now we have
the
to come up
mechanic?
with,
What's the incentive?
yeah, exactly. So I'm thinking you pay a small amount of money to roll, right? Every roll costs a little bit of money.
Yep.
And then if you hit a specific set of numbers, maybe if you get, okay, so let's say we're out of 255 or out of 100 or something. Maybe we do out of 100. Then it's easy to do the percentage, right?
Sure. Yeah.
So if we do mod 100 here for our console log, so get random just gives us a mod. What you would really do is maybe even have a UN8 come in and have it do mod by whatever.
Yeah.
Okay, so we're going to roll and we're going to get from 0 to 100. So maybe like 10% of the time they get their money back. Like if it's a 0 to 10, you just like win your money back, right? Yeah. And then like 90% of the time the money gets stuck in the contract, but then there's like a small percentage of the contract pays out the whole amount that's
right,
or the contract pays
well, let's do 1% of the time you get the pot, 9% of the time you get money back, and then
money
90%
back
of the time it's like you lose your money to the contract.
Perfect. Okay, so we need to kind of keep track of a variable then, right? We need a UN8 that's like the roll or something like that. No, we won't want to store that as a state variable though. I think it'll all happen right here in our roll. Okay, so let's
rename this to be
back.
like roll the dice, I guess, or something like that.
Yes, let's make the function a write function and let's make it a dice roll. Yep, exactly. And it won't be view anymore, and we don't need to return anything, but it will need to be payable. Right. Yep. Okay, and so what are we going to require that they pay? Do we have a price to roll?
Over 0 at least, but maybe there should be a minimum price.
Maybe we set the price exactly, right? We have that price up there at 0.001 ether. It's already written into our contract from something else. Like, let's see, what is that? That's $1 right now. Is that right? It's probably not even okay. So we want to assume that if we're going to put this on Robston, it's going to cost you like maybe even a couple bucks if we put this on mainnet to roll. So the price needs to be almost above that. Let's see.
That's true. To like be more than the gas fees.
Yeah. Like what about if it's like 0.025?
Okay.
I don't no, just 0.025. So yeah, there we go. Right. That's about $25 if ETH is at 1,000, I think.
Yep.
Okay, cool.
Yep.
All right. So let's make sure that the message value is equal to price, right? If we do greater than or equal to, if the only reason you'd want to do greater than or equal to is if that price is slowly moving and you want to have a little bit of a buffer, but let's just do equals just to make sure that they don't like put in 0.25 on accident, right? You have to put in exactly the price. Yeah. Yep. I like that. Didn't meet. Okay, error messages. And what's hilarious is like, since we're not using custom error messages, we're using require statements. That message actually costs you money. Like when you deploy the contract, you're paying for that, whatever that message. If you have
that's what I figured, because I noticed that
it's going to cost you more.
Will have like very, very short messages.
Yes. Or yep. And whatever, it doesn't like, not perfect. Okay, so they go to roll the dice. They pay in some money. We make sure they pay. Then we get the randomness. Okay. So this is where, like, about line 23, we probably need to track some variable called roll, right? We have a UN8 called roll, and we set it equal to that mod 100. Yep. There we go. Okay. And then we just need a big ass if statement, like all good programming, right? We need to say if roll equals 99 or something like that.
Yep.
What do you 69? Should we do 69? 69?
69 will be the 1%. I love it.
Yeah.
For the culture.
If you for the culture, it's for the vibes. If you hit exactly a 69, we're gonna pay you out like 90% of what the contract holds, right? Okay. And then there's an else if, and that would be if your numbers maybe greater than 91 or something like that, right?
Greater than, I guess it would be, yeah, it would be 0 to 90, right? So greater than 90?
Greater, yeah. You could
equal to
just
90?
greater than or equal to 90. Yeah, I don't
Yeah.
know. It's like this is all arbitrary garbage that we're making up on the fly. So
Yeah.
it's not like it needs to be. So about 10% of the time, it's kind of like when you roll a slot machine and it's like cherries. You don't win the big pot. You just win like, here's your money back for trying, right? Maybe we even like give them double their money back, right?
Sure.
Like maybe, or maybe it's like 1 point. Well, so you pay 0.25. Maybe we pay them back like 0.05 or 05. Yeah, exactly. If they, we'll come up with that, right? You get a small prize, right? Yeah. There we go. And then let's see, you get a large prize, you get a small prize, and else womp womp, your money just is left in the contract, right? Pretty good. I think we need to write the sends now, right? I think we're,
let's do it.
Yep. Okay, so let's figure out how much we want to send in this case. In the very large case, we want to send them.
Let's start with this one.
It's going to be,
because this is the one where people lose money, so we can accumulate the money first.
I think it just stays in the pot, right? Nothing happens, right?
Got it. Because you're paying the function, it just goes into the contract. Got it. Okay.
Yep. It'll just live in the contract, right?
No logic needed. Yep. Okay, cool. And then
man, you know what though? I kind of want to like, let's say there's some beneficiary too. Let's say that when they lose, a small portion of that goes into some public good or something like that, right?
Okay,
so we make this like a gambling.
You don't feel super degenerate, just like gambling.
Yeah, exactly. So we'll need some address up in the top. If you go like line 15, we need to keep track of some beneficiary.
Yeah, okay.
And in this example, I'm probably just can we do build guild or something like that? Do you have a good public good? Fine. Okay, let me get the build guild. I think it's just buildguild.eth. I'll find it for you. Yeah, if you just do buildguild.eth and it's biddle. Yep. There we go. That's the one. Let's grab that address. And so this won't actually work on some this is only going to work on mainnet, so I don't know what we're going to do about that, but yes. Okay, cool. Awesome. Okay, so let's say in the losing case, let's send like point, I don't know, like 0.0. Oh, okay, let's see. So we want to send like
0.01, maybe half.
0.005, maybe like a fifth of the money. Is it like, so 0.005 goes to build guild or something like that if they lose? So it's like, it's like gambling for public goods or something. Okay, so we don't want to do beneficiary.send. Okay, now here's the thing though. You don't want to do a .send or a .transfer. This is just a big gotcha in Solidity. Almost everyone goes address.send or address.transfer. The problem with that is the gas limits are weird. And if you're sending to a contract that has to do a little bit of execution, it's going to need to spend some gas. So if you just go to Solidity by example, there's a really good page for how to send ETH. It's Solidity by example, sending ether. Scroll down right there. Yep. This is just go here and copy paste every time. This is what I do.
I love it.
Scroll down to line that last line right there. Yep. We need both of those. Yep. Copy and paste both of those over. Yep. To there. Okay. And so we'll say .2 is the beneficiary, right? So you'll do beneficiary.call. And the value will be 0.005 ether. There we go. And then you can delete the bytes memory data, but leave the comma in there, and it'll get rid of a warning, because it's going to give you a warning that we're not using the data, and we don't need that data either anyway. So on line 35, it says bytes memory data. You can trash that.
Oh, got it.
That right there. Yep. Just leave it just like that. Okay, let's see if that compiles. Let's just do a yarn compile. We don't even need to deploy it. Let's just do a yarn compile and make sure it's happy with us. Okay, so now we have our nice little send though. Oh boy, public, maybe wrap that in payable. Oh, checksummed. It's mad about the checksum. I think you might have to go back to Etherscan. It's all lowercase, and you need it in the checksum version.
Oh, okay.
You could also just like Google checksum Ethereum address, but maybe
Wait, sorry, I'm not understanding. What's the issue with the checksum?
So look how the address owner on line 13 has some capital letters in it.
Right, right.
The way the checksumming works is it only capitalizes some of the letters. Yeah, see, oh, it's right there. Actually, can you copy that?
Yes.
It was like in the error message. See how it has capital DD
Oh,
up there, the address. Yeah, that. Yeah.
nice. Okay.
We need that. It's some dumb shit, but yeah, there we go. Now it's probably happy with it. There we go. That was a good thing to just check real quick, though. That's why we got to do that yarn compile now to make sure it's right. Make sure that compiler's happy. Okay, so let's go look at the other two paths. If you roll a 69, we want to send you 90% of the money in the contract or something like that, right? But let's do this simple case. Let's do the second simple case. Let's do the 90 first. If roll is greater than 90. So let's just copy paste in the instead of the beneficiary, it's going to go to the message.sender, right?
This one right here.
Oh, there we go. Oh, there we go.
And then we would want to send like
just programming in the janitor's closet. Alchemy.
Yeah, the freight elevator.
We need some snacks and some toilet paper. What do we decide to send them? 0.05, right?
0.05, yeah, like double the money.
Yeah. Oh, but what if it fails? What if there's not 0.05 in the contract? Shit, I didn't even think about that. Because
we should send at least their money back do a send
and require. So require that 0.025 goes back, and then do another message.call, but don't require that send works. So like we'll send them their 0.25, and then we'll try to send them another 0.25. How's that sound?
Okay.
So you'll just
also what's happening though is that they're like spending gas money to like do the transaction, right? But that's
it's
like
so cheap.
That's just on them. Yeah.
It's not like 21,000 like it is when you send like the overhead. It's gonna be super cheap to send ETH. Yep, you got it. Just set one up to do. Yep. IDK about requiring. I don't think we want to require because we'll require the sent on the second line. I think you want to just copy paste the line exactly. Yeah, maybe that'll work. I would just copy paste that line. Yep. And then I would set.
We don't need the.
Yeah, you don't need that. You could probably take that stuff off. Yep. And then do 0.25. I think this is gonna work. It's not liking it though, is it? And then try sending the price again. What's it saying?
Oh, the return value is not used.
Okay. We'll deal with. Yeah, that's fine. And then do do price again right here. I don't know. It seems like it'll work. Wait.
That makes sense, right?
No. We want to do the one where it doesn't check it after the first one. So we want to send them 0.25. We want to double check that worked. And then we want to send them another set of price. Yeah, copy that to the end. And it's okay if that one fails. So we're just not requiring the sent is set let me do this. Correctly. So
we're duplicating this and we don't.
And then we're not requiring it. That's it. Yep. There we go. And in that case, yeah, I think you just trash it. It's gonna complain now. But I think we're fine. Let's just, this is we're gonna be okay with that warning.
Yeah.
Yeah. Okay. And it's like, yeah, we know that. Okay, cool. Okay. The last case is really interesting, right? We need to do another bool send. So you can grab 33 and 34 and bring them up here.
Yeah.
But it's not going to be price. It's going to be the address this dot balance.
And then like,
so you'll do, yep. So do, address like times 90 divided by 100, right? Is that right?
Yeah.
I think that's right.
Sweet.
And there's only one way to find out. Let's test it in scaffold-eth. Oh man. Okay, so hold on. This is going to be really hard to test because it's going to be hard to get randomness.
Right.
So let's cut down the roll into like I don't know, like 6 or 10. Let's make it a dice roll real quick.
Okay, let's do 6.
Okay, and let's console log the dice roll so we know what the roll. Let's just console log roll there so we know what we're getting every time. There we go. Okay, I don't know. Let's go play with this. I think on local.
Oh, but then we need to change this logic too.
Yes, you're right. Yes. So if roll equals 5, maybe. It won't be 6.
Yeah, you're right. 0 to 5.
Yep. And if it's greater than
1,
4.
Well,
3, greater than or equal to 4. Okay. Either way, it doesn't matter. So basically, let's see what happens.
3 and 4. Okay.
Yeah.
Oops.
So this is going to pay out like crazy, right? Like it's,
Right.
yeah. So if you are 3 or above, you get your money back plus some. Maybe we should set that to at least a 4, right?
So then, but then that would just be because like then.
Oh, you're
five is
right. That's
accounted
already the
for.
5.
Yeah.
Yeah. Okay.
So
This
would
will
just be
work.
3
It's
and
just
4,
gonna
yeah.
like pay out like crazy,
Like half
right?
the time, yeah. More than half the time it'll pay out.
More than
let's
half
do
the
4.
time.
Let's do 4. Let's do 4.
Okay. So if you get a 5, you get 90% of the contract. If you get a
Right.
4, you get your money doubled, maybe if the contract holds it.
Yeah.
And then if you don't, then the money just stays in the contract. But we send a small amount to the build guild as a public goodsy thing.
Exactly.
Okay, let's go play with it. Let's see what happens.
Okay. Yeah,
then this is what it's all about. It's just like make small changes, get the thing figured out, get it working on localhost, and then deploy it.
Yeah.
Okay, so we need to pay for the dice roll, right?
Then,
So you want to put in
what,
0.025?
I could just copy this.
Yeah, but you need to hit the green. Yep, there you go.
Okay.
And then roll. Oh no, you need money. Yep.
Money.
So here's a cool way. You can copy your address. So grab that copy and then go down to the bottom left. There's a little wallet down by that local faucet. So you could paste it in, but you can even open up the wallet. Okay, so we'll open up the wallet, paste in your address, and send yourself like $1,000. And then
oh my gosh, there's so much. Yeah. This is all local.
That's the hard hat. Yeah, that's the hard hat. Yep.
Got it,
so go ahead and hit send here. There we go. Now we have like 10 grand, right?
Yeah.
Yeah.
I'm rich.
Okay, roll it. All right. Now let's go look at the hard hat so we know what we just rolled.
Right. Okay. 2.
There we go. So we rolled a 2. So the money should just stay in the contract, right? Basically, 0.02 should be in the. If you click that 21.5 in the top right there, it'll change it to ETH and it'll make it more sense right there. Yep. So 0.2, and that's right. So the 0.005 went to the build guild. The 0.2 stayed in the wallet. Everything worked. All right, let's roll again. Awesome. It's working. All right, 0.4. We must have rolled another low number. If we could look at the hard hat, 0.6.
We're losing.
This contract is 2.
Did we roll 2 each time? Oh, we rolled
a 1, a 0. Keep going.
Oh, that one did something. We rolled a. Oh no, that went in.
No, so that keep rolling. And then let's watch. Oh man,
that was a 2.
We're doing terrible. What is happening? Oh, I wonder if. So the block.difficulty isn't a random number right now. I wonder if the way. Okay, we're okay, and it's hashing correctly. We're getting close. Yep. Let's keep going.
Okay. Oh,
we're really bad at this.
Yeah. No luck.
My goodness.
The randomness is against us.
Is it? Oh, maybe this is working.
Boom.
Something happened. There we go. Yeah. Okay, what just happened there? Let's go back and let's debug that.
So we got a 5 this time.
We got a 5, which should be the major payout, right? And it was, right? It was at
it was at like 0.18 or something.
Yeah. Yep. And it went to okay, I think that worked. So the only other thing is we need to see that it gives us a little bit back when we get a 4. So let's just keep rolling a little bit and we'll know right away by watching the total value of the contract.
Yeah.
Okay, so it didn't work that time.
102 up.
Didn't work that time. Oh, that might have been a 90.
I think that was a jackpot, yeah.
Yeah. Yep, another jackpot.
All right. 102. 102. Oh, 0.02.
Very slow. And so, okay, so now I'm thinking about the front end. Before we deploy this thing, we probably want to have like a nice button that lets you roll the dice and gives you feedback on what you rolled.
Right.
But we're just not going to have
we got
time
our money
for
back.
that.
Oh, no.
Did we?
No, we didn't. Nope. It was just slow.
Okay. Let's try it again. Let's get a 4 real quick. Yeah. I'm worried that like we're not going to have enough time to build much of a front end. We may just be like using this front end in production, which is kind of sad, but that's fine. Keep going. 0.12. Jackpot again, right? Dang it. We need to get a 4. So we need to get, we have 1 out of 6 chances to get this right.
Wait, I think we got it actually. Before this 3. No.
Was there?
No.
Okay.
Did that go? I'm losing track. There we go. 0.06.
0.6. 0.8.
Okay.
And what we should see is it go down by 0.2 when it works.
Right.
Okay, keep
right.
going, keep rolling, keep rolling. Come on, keep rolling.
Wait, it wouldn't go down though, right? It would.
It should go down a little. It should go down the amount that you pay. Because if you put in 0.25,
It would. Oh, right. You're right. Because we're sending.
it should send them the price and then
Yep.
try to send them
You're
the
right.
price again.
You're
So
right.
we should see it go down by
You're right.
2
Right.
instead of going up by 2.
No.
Another jackpot.
We're getting a lot of jackpots.
I mean, it's a 1 in 6 chance. We should get it here pretty quickly. Unless we're doing something wrong.
Yeah, with the probability.
Yeah. Let's go a couple more. Oh, there it was. That was it.
There,
It
yep,
just
that
went
was
from
it, that was it,
0.11 to
that was it.
0.9, right? Go
That
back
was
and
it.
look. I bet that was a 4. If
Yep.
we look at the okay,
I'm
I'm happy with
Four
it,
was the
right?
real
I would say we've audited this contract sufficiently to put it on Ropsten, wouldn't you say?
I agree.
Okay. Okay, so let's go back to let's go back to that.
The configuration file.
Yeah, well, no, we need to go back and change our numbers. Basically,
right.
mod
Back.
169. Gosh, you know what we should do? We should have an event and we should throw the event out just to make this work in the front end.
Yeah.
Yeah. Let's set up. Yeah, exactly. Dice roll and do address indexed so we can have it indexed by who sends it. And then uint 256 of what they rolled, and then a uint 256 of payout. Do we really even need payout? It might be nice.
Yeah, it might be nice so that we don't
Might be nice, right?
calculate it ourselves.
Yeah. There we go. And you could trash the set purpose event there too. We'll go steal that in the front end eventually.
I don't need the purpose here.
Yep. And you don't need the set purpose down there either. Yep, there we go. And it might mess up the front end. We'll see what happens. We may need to have that in the or like fix the contract. Okay, let's see.
Okay.
So roll 69, roll is greater than 90. We send the price. Now we just need to emit the event.
Oh, for each one.
Emit in a different event for each one of these. Yep.
Yeah,
Ooh, 15 minutes left. Can we get this all deployed in time? We'll see.
Emit dice roll, and then it's this
Message.sender, right? And then price. No, roll value would be roll. Yep.
And then the payout is
The payout here. Ooh, we probably want to put that into a variable. Yeah. Nice. Nice.
We want similar logic for all of these actually. So maybe
Yep.
we just do it this way at the bottom. And then
Ooh, and have payout
yeah.
a variable that gets set up here, and then we set it in different ways. Oh man, the middle case is actually a weird one because you'll set payout equal to, it's fine, it'll work. You'll set payout equal to price on line 30. Yeah. And then we need to get the logic. We need to get the bool sent. So yeah, we need the bool sent for the other send. So you'll copy the bool sent parentheses on line 37 and paste it onto line 39. The bool sent equals.
Why do we need
You know what
it?
I'm talking about? Yeah, that stuff right there. Because we need to increment the payout by the price if sent is true.
Right.
Right.
Got it.
Right. So we say if sent, payout plus equals price.
Yeah, if it was successful, then
Yep.
for logging purposes, record the new payout.
Yep.
Yeah.
Super weird, but yeah. Payout plus equals. Oh yeah. No.
Wait, can we do plus equals? Is that?
Oh yeah. Oh yeah.
Okay.
Oh yeah. There we go. All right. And then finally there would be no winner in this case, right?
Yeah.
So
payout is
maybe
0.
should we do the roll? Should we still? Yeah, payout is 0. It's fine. Yeah. Okay, that looks good. Maybe let's run it once or twice and make sure it looks good. So basically, we probably won't have time to like read the events. We could look at it in the front end, but I guess it's going to break. But after we get this thing, I don't know. Let's just know that the the events are there and they're fine and they'll work once we build them in later. But we need to get this thing shipped, and we can like, let's see. Let's just roll a couple times and try to make sure it works. Okay. And if you go to example UI, does it totally blow up? There's a little example UI tab. It doesn't. Okay. And if you scroll down, what we want, there's like an events example down here.
Oh,
yeah. Okay. So it's empty. Let's maybe
okay.
go edit that real quick and see if we can get that to start showing roles.
Is that an app.js?
Let's see. So you'll go to, it'll be example.jsx, I think is what you're looking for. Example UI. Yeah, there it is right there.
Oh, nice.
Yep. And then if you scroll down to the event, yep, it's your contract, but the event name is dice roll or something like that.
Yep.
Right. And we're actually going to have to go edit that events component. This is a really weird way with how they set up events in scaffold-eth.
Okay.
But yep, right here. So here's where it's displayed. The argument 0 is the address. Then it has arg1. On the next line, you see the arg1. That would be the amount they rolled, right? So you could do a 2 number on that. So line 36, just hit save. It's gonna fail, and we're gonna get something blowing up in the front end.
Yep.
Yes, objects. So what we need to do is do a 2 number to that object. So right where your cursor is, just do 2 number. Yep. And let's copy paste that whole line, paste it again, make another line for argument 2. Yep. And this will be their payout. So you'll format ether, I think, on that, right? So it'd be ethers. Yeah, right there. Ethers.utils.format ether. And then you'd wrap the arg2 with no 2 number. You don't need a 2 number there. You can delete the 2 number. There we go. Let's see if it likes that. Ethers might, oh yeah, you need to bring ethers in. Sorry. So if you scroll up, let's see what's going on there. Yeah, just grab, import ethers from ethers. Yep. All right, then we need to go roll a couple times. Wait, why is it 460? I don't think I understand that.
The payout should have been 0.02.
Let's roll a few times and then let's go look at the
Yep.
Yeah, just hit it a few times. Tap.
Oh, it'll just stack.
Yeah.
Oh, it's loading fast. Oh, okay, it's pretty fast.
No payout has happened. So now we're like, it's going to be like a 1 in 100 chance to get a large payout. Okay, then let's, we may have won 1 or 2 paybacks, but we definitely haven't won the pot yet.
All right, let's check the events.
Let's check those examples. Okay, what
is this? This is supposed to be
why is it 2 different numbers? Is it maybe a 59 and then 0.0? Can we put just like a padding around that? So let's go back to the event component and do a div around line 38. Just throw a div right there. Yep. And do maybe even style padding equals 8 or something like that. Do you F around with front end stuff much? Oh yeah, you're doing it. Oh yeah. Oh yeah. Oh yeah. Nice. There we go. That's what we needed. That's what we needed.
Okay, nice.
Okay, good. So it's basically working. Do we see any 90s in here even? Let's keep rolling a few more times. Let's get at least 1 win before we ship this thing to production.
Sounds good. Okay, go back.
Do you have a call at the top of the hour? We might roll over.
No, I can go. I can keep going.
Okay. Yeah. We might roll over just a tiny bit, but I think it's worth putting this thing all the way out there.
I agree. I think this is pretty fun.
Oh, dude, we need a dice roll button. And I think this will show the front end way better. Let's do it. It'll take us 2 seconds.
Okay.
So go back to your example UI.
Yep.
There. Okay. And at the top of the example UI, there's a button that's called set purpose or something.
Sorry, I'm gonna see the
yeah. See that set purpose button? Let's turn that set purpose button into the role, right? Let's see. Keep scrolling up. There's a whole bunch of example buttons here, and you're looking at the example buttons. There's example buttons there. Yep. What we want is so if you go back to the code and scroll to the top, there we go. There's that button right there. It's line 41. It's calling write contracts.yourcontract.
Got it.
Right there, dice roll or whatever. And then inside of the parentheses, we need square braces because we're going to send value. Exactly. Yep. And that's ethers dot
Oh, yeah. Yeah.
No, you'll have to do ethers.utils.parse ether. And then in quotes, you'll do, you got it, sir.
Oh, is there a
Nice
point?
work.
Okay.
You've
Yeah.
done this a few times. All right, let's try that. Let's try that and see what works. Let's change the name of it to roll too,
Oh,
where
yeah.
it says set purpose on line 60. All of this other stuff here from line 42 to line 59 is all just like a callback and giving you information about the transaction. The calling the transaction is that one line. Roll the dice. Very nice. All right,
Nice.
there we go.
And then
Let's try rolling the dice a few times.
Okay, sweet. I can delete this though.
Yep. And let's even maybe like take out the rest of that UI.
Yeah.
Let's take that button. Yeah, just delete. Yeah, delete all that shit all the way to like
to the buttons. All the buttons, all this.
Yep. I think you might have an extra /div there. Yep, kill that. And then down a little farther. Let's see. Oh, that's nice.
Nice.
And then maybe the example UI and the purpose we could even take out.
Oh, yeah.
Yeah. Now I'm wondering if there's a way we could reverse the events so you see the latest one at the top.
Right. Okay.
Dude, IDK. I don't think we can do that without doing something weird. Let's see what's going on in
maybe
here.
There's a React list orders styling or something like that.
You know what? Line 26. This is where we're getting into all sorts of stuff. Let's just do a use effect. Let's do a use effect. Let's do a use effect on events.
Okay.
And we'll have some state variable called saved events, and we'll set them equal to hopefully your React is better than mine, because this would take me a minute.
It's not probably. So this would be an array,
that's a use. Isn't it a use state?
Oh,
do you do that's use state, and that'll just be I think so. And then we do a use effect
on that list. Okay.
Yep. We'll do a use effect, and it'll be events reversed, and we'll set saved events to events reversed.
Right. So
and then we'll only
standalone function, right? I forget.
Yep. It is. And then inside of it, it's a function and then a comma. I think you just do use effect parentheses.
Use effect. Oh, because you're calling it. In a callback function.
Yeah. Inside of there, you put the function. Yeah. So you'll do more parentheses and an arrow. Yeah. There you go. And then after that, there's a comma and then square braces. Line 30 between the brace and the parentheses.
Okay.
Yeah. And then in there, we'll put events, right? Anytime the events change, we'll trigger this use effect.
Right.
Line 30 in the square braces, we need events. There we go. No, just events. Because we're going to set
coming from
right line 25. That's coming from the event listener.
Okay.
There we go. So we're saying anytime the events update, run this use effect one time, which basically sets the saved events to events.reverse or something like that. Do you do .reverse with parentheses maybe? Like it's a call, right? Yeah. And then will this work? I don't know. And then we need to display saved events. So on line 36, we have the data source of events. Well, that needs to be saved events.
Yeah, you're right.
Right.
Well, actually, so we could actually just do this.
And it will just reverse it.
Yeah, I think so.
Oh man. And we don't need to have any. Let's see what happens.
This actually, yeah. Let's delete that.
IDK. Maybe. Let's see.
Use effect is not defined.
Oh, you have to bring it in React. Yep, that's exactly what I do.
Oh, got it. Okay, I gotta do this.
Yeah.
Okay.
Yep. And there's probably something similar to that. Nope, there's no React stuff coming in. Yep, just paste that line in.
Okay, should work. We don't need the whole line, but whatever.
We'll take some warnings. We don't care.
Yeah.
We're trying to ship something in 10 minutes.
Right. Okay. Use effect is not defined.
Is it still doing that?
Oops. Events.reverse is not a function. Reverse array.
Reverse. I think it's just you have a reverse. It's just reverse.
Okay.
Yeah. There we go. That should work.
Nice. Okay. Let's see if that did a thing.
What we want to see is.
Yeah.
Wait.
It's updating.
Yeah, but it didn't slide it down. Maybe it's working.
No, that's weird.
I think it might be working.
Oh no, it is working. Yeah.
The 46 and 9. Let's roll a few more times.
Here, 46 go here.
We should see 46 and 9. Yeah, it's weird though, right? It's like a little bit different. Yeah, it's shuffling them.
Oh no, but then it resorts it.
this use effect is strange.
Yeah, it is. It shuffles it twice.
I
but then
think let's do the state
it ends up
variable.
stable.
Let's do the state variable. It's
Okay.
not that much work. Just like undo a couple times and have that state variable there.
All right, let's try that. Refresh that. Okay, roll the dice. Okay, yeah, that's smoother. Yep.
I think it's working, right?
I think
All
that's
right, let's
working,
roll
yeah.
until we win at least once, so we see that there's a payout too.
Right. Okay. I'm just gonna keep clicking it.
Yep, and this time it won't get in your way, so you should be able to.
Please load.
1 in 10 chance. We're still not there, right? It's got to be greater than 90.
Is it
Or
loading?
greater
real
than or
time?
equal to?
I think it's like
is.
backlogged.
Well, yeah, it'll take you a little bit to like display. But yeah, you're doing it right. We'll get a big list of them now.
Yeah.
Ooh, a 0. That could have been a fun one.
I know. Or 42.
Yeah, 42 is another one. 69.
69. Oh,
isn't that? Yes. Huge. It's huge.
Yeah, we got a couple.
What
Wait,
the
these
heck?
payouts. Wait, hold on.
Yeah. Okay, no, there's a reason for this.
Race condition.
It's because the block.difficulty isn't changing. So
oh,
yeah, so right now the block.difficulty is some like local variable, and so there's
Yeah.
not a lot of actual randomness happening here.
Yeah.
So once we get to Ropsten, it'll be more random, which
Mhm.
probably could have caused other problems with things like basically if you catch it in the same block, right? Yeah. So
yeah.
hopefully
Hey,
this
give me
works
1
better.
second. Let me double check my calendar real quick.
Yeah.
Okay. All right, cool. Let's see what we can do in 5 minutes.
10 minutes, 5 minutes. Let's go. Oh, do you have something?
I do.
Okay,
Actually,
so
I forgot.
okay, we need a yarn build.
All right.
Right?
Let me
Let's
check
get,
my
oh, no.
schedule.
We need to deploy. Let's deploy to Ropsten, right? So we need to yarn. Okay, so you've tinkered with scaffold-eth. You've
Yep.
got your build ready to go. You're
Yep.
ready to go to production.
Mhm.
Let's go to, really what we would do is carve this out so it's only the example UI. We wouldn't have all
Right.
this other shit, but like
Yeah.
we're in a hurry. Let's do this.
Right. We can do it
Okay,
like
so we
second
need
iteration.
to do a yarn generate,
Okay.
and that's going to create a deployer
right.
account.
Yeah.
And you've done this before. I've seen you do tons of demos where you create a deployer account and you put it into a .env file,
Yeah.
and you hide that
Yeah.
env file. And there's
Yeah.
some weird things where you're copy pasting private keys around
Yeah.
and silly shit like that. Nothing here. It just generates it for you.
I love
right?
this. This is so
Yes.
nice. It's
And
one
if you
command.
do yarn,
add in
if
2
you do yarn
seconds.
account,
Yeah.
you'll see that account, and it'll even give you a QR code.
Oh,
if
yeah.
you stretch that QR code out, I can send you some Ropsten real quick, and we could
Okay.
deploy this thing to Ropsten.
Yeah, go for it.
Okay, let's see. How about Ethereum? Ropsten, here we go. All right, and I'm gonna scan. I'm using a burner wallet. Right, I'm
Nice.
using built with scaffold-eth. Yes,
Nice.
very nice.
Punk wallet.
And I'm gonna send you Punk Wallet. I'm gonna send you $200 of Ropsten. And
while he's doing that,
it's
shout out to
going.
punkwallet.io.
Word.
You can get your
Yeah.
Punk wallet here.
Yeah,
Yeah.
awesome. Look at that character.
Yeah.
There we go. Yep. Okay, so hopefully I just sent you some Ropsten ETH. It should only
Okay.
take 15 seconds and should be, so
Okay.
now when we're ready, we're gonna do a yarn deploy.
Okay.
Oh yeah, let's see if it loads up Ropsten here. Covan, mainnet,
Boom.
Ropsten, there you go, we got money. Okay, so
Okay.
let's do a yarn deploy -- network.
Cancel this. Yarn
Ropsten.
deploy network Ropsten. So you just forward this to the hard hat command, right?
Yep, exactly. Yep, and so hard hat is now deploying our contract on Ropsten, and we'll get
That's
an
the
artifact
transaction.
back. Yep, you could go
Okay, we're
check the
still waiting.
transaction if you wanted.
It's like Ropsten.
Yep. Okay, so there's one other change we need to make in the front end before we can get it starting to build.
Okay. Yep.
Let's go to our app.jsx while
Yep.
we wait for that contract to deploy.
Okay.
And at the top of app.jsx, there's a network selector. Scroll down a little bit farther, right? It's probably not. It's right there. There it
Yeah.
is. Line
Oh, Ropsten.
56. We want networks.ropsten. And
Nice.
by making this small little change, everything in our app is now pointed at Ropsten.
Mm.
All of the addresses, when we click them, will take us to Ropsten. So go ahead and save that, and let's go
Yeah.
see what the front end looks like.
Cool. So even on localhost, it's pointing at Ropsten test.
Now it's pointing at Ropsten. Exactly. Yep. So you'll have to reload. Yep.
Boom.
So now we're on Ropsten,
Nice.
and at this point, you would connect your MetaMask, right? You would actually,
Or can I connect to the burner?
yeah, or just create a burner wallet, and I'll send you some value.
Oh, but I can't-
don't do this burner. Do a different one.
Right.
The burner wallets.
Got
Don't
it. Okay,
copy
wait,
and paste
do this one,
addresses,
do this
just-
one, do this one.
What do you got?
I got this one. Maybe
Oh, no, let's not send to this. I guess, I mean, technically you could connect, you could wallet connect in as this one into that app, but instead, let's just go back to your app real quick.
Oh, got it. Okay.
Yep. And go to the wallet and go to receive. You could wallet connect in here, but let's just send some. So just go to the wallet icon there.
The wallet icon, this one.
Top right, to the right, that right there. Yep. And then click receive. Don't click private key. Click receive. There we go. And then I will send you another $100 of Robston. Okay, there you go. Robston on the way.
I didn't know there was
you should have some in a little bit. Yep. So you can close that. You should have some money in a little bit. We should be able to roll the dice momentarily.
Okay, sweet. I'm just gonna refresh a couple times.
Come on. It should take about 15 seconds, right? Robston's pretty
yeah.
Now that it's
active.
Still there it sent, I think. I just got the update. There we go. Okay, now let's try rolling the dice on Robston. Here we go. Robston transaction. There you go. Notice nice little, now we have block native notifications. Nice little notifications instead of
nice.
Yep. All right. So we're actually rolling the dice on Robston. Okay. So what you would have to do to deploy this, it worked. Holy cow. We got our money back.
We got our money back. Yeah.
And we didn't, and we, that just tested that the fail case works.
Right.
It just tested that the payback, the weird payback, we just tested on the first
I love it. We hit everything.
Yes. Okay. So the last thing we need to do to put this thing out for public use would be to build the front end. So if you just go to a command prompt and you do yarn build. Yep. And let's get that started. Let's go do some rolls while we're waiting. Right. Okay. Yeah. Roll those dice. Click it a couple times. Right. Like what happens? Oh yeah. Already known. Oh, maybe it
there's
doesn't
like a
increment
nonce
your nonce. Yeah.
I gotta wait like a second.
Yep.
Nice.
I like this. Look at that. Queuing up some transactions. It's all those 11 a.m.s letting you know that you have a call right now. There we go. Transaction succeeded. What do we get? Oh, look, we got the same number over and over again. Okay. I think we need a nonce. I think we need a nonce in the contract, and each role is going to have a nonce, and that nonce needs to be part of our hash because the block.difficulty is changing, right? Yeah. And it's too late to know that now. We'd have to go back and build it in, but we know it. We know now that
we know it thanks to this fast feedback loop. We can like test it.
Yes, exactly. Try it, test it, ship it, see what happens.
Love it.
Okay, so technically this is working. Is our front end done building? I was wondering if we could surge this up and I could go roll. No, it's going to take a little bit. So what we would do here is as soon as this finishes, then you would do a yarn surge. Yep. And that would take your build and it would put it up on Surge. And then I could go to whatever the address is .surge.sh and I could go roll the dice. I could connect my MetaMask and I could roll the dice. Yep. Yeah. So yeah.
Wait, okay, let me push back my meeting by like 3 minutes. I feel like we can do it.
Okay.
Give me 1 second.
Send him a message. Yeah. Okay. Gosh, it wouldn't be that hard to put that nonce in either if you wanted to say 10 minutes, but maybe that's too much. We could do the nonce as another thing. Like we could do another build and put it on mainnet or something.
Yeah. We can do it for the follow-up.
But we definitely need, I think what we need is a nonce here. And each roll increments the nonce and the nonce is part of the randomness, just so you can't get the same random number on the same block.
Right. Okay,
there we go.
That's finished building.
Okay, yarn. So you'll do a yarn surge now.
Yarn surge. And I have an account already set up. That domain is fine.
What are we going to call it? Yep. Ooh, that might already be taken.
Oh, okay. Let me rename it. Let's actually call it
diff roll. Because it's like a difficulty
roll. Yeah. And then do I have to call it .surge.sh?
Yeah, surge.sh. Yep. Okay. There we go. Okay, I'm going to steal a screen.
Nice. All right, it's published.
Okay, so I'm going to go to diff-roll.surge.sh.
Nice. It's on the internet.
Yes, it's created. And I'm going to go to example UI. And I'm going to connect my MetaMask. Yep. And then let's see if I log in here and wait for MetaMask. We're waiting. We're still waiting.
I love that you have the beacon chain on the background there. Like
you gotta have it. Yep, you gotta have it. There we go. And this thing should detect, right? I'm still waiting for MetaMask. I click the button and I'm like waiting for it to move. Okay, there we go. And we get this nice thing like, oh, hey, this needs to be on Robston. Don't forget to move your wallet, right? So whenever you build an app with scaffold.eth, all of this stuff comes out of the box. And now we are ready to roll the dice.
Nice.
Yes. So we were able to go from 0 to 1, really. We came up with an idea of making a dice game, right? And you were able to push it all the way to a production URL where I can go roll the dice. And instead of deploying to Ropsten, we could have deployed to mainnet by just doing -- network mainnet.
Right.
So basically, like, we were able to go from idea to production smart contract app. Obviously, it's ugly. You'd want to clear some stuff out, maybe spend like 10 more minutes on the React, making it look a little nicer.
Yeah.
But basically, we've got an app that people can play.
I love it.
So
if I wanted to update my deployment, how do is that included in the search command, the yarn commands?
Yeah. Okay. So you're saying if we like added a nonce to the smart contract.
Yeah.
Okay. So
I changed the UI and I want to redeploy the UI.
Yep. You would just do a yarn search. You can even do yarn search -- domain and whatever the domain is, and it'll overwrite the domain if you want.
Got it.
Right.
Nice.
So what you would do, okay, so we went from 0 to 1, but if we wanted to go to 1.5 and make it a little bit better, you would have a nonce as a state variable, and that nonce would ++ every time someone rolls, and it would be part of that hash.
The hash for the random number.
Right. Yep. So we have difficulty hashed with a nonce, so then it's going to be a different roll every time. And even if someone rolls in the same block, you get a different, and then you would yarn deploy, and then you would yarn build, and then you would yarn surge, and your app would now have the new smart contract with the new UI.
I love it. I'm going to ETH NYC hackathon in about a week.
See you there.
Yeah,
yes, I'll see you there. Let's do it.
Scaffold-eth. Maybe I'll build something.
Heck yes. It's like it is like the hackathon stack, right? It's a way to quickly iterate. Okay, you got to get to your meeting. Albert, this was a lot of fun.
Awesome.
Dude.
This was a pleasure. Thanks so much.
All right, see you.
Talk to you later. Bye.